Hi. Like I said, I'm Norman Mier, and I'm with Best Incorporated. I am an MIT. I sit through the review for the revisions for E to F. I'm also on the committee for the training material. Training material, the beta edition is not going to be out until February, so the new course probably won't be out until March or April next year. So I'll go ahead and give you a heads up on that. But you can go ahead and use the latest revision in your companies, because the Rev E is gone now, but the training still will be to the Rev E until the Rev F course material is available. And if you are instructors, you can, when you get the new revision, you just keep on teaching. You don't need to go back to the class. You just keep on going with it. But again, welcome. I'm Norman, and I'm with Best Incorporated. So let's have some fun for the next 45 minutes. And at the end of the PowerPoint presentation, I'll open it up to questions and answers. Okay? So here we go. First thing that we want to look at is what we've done was try to split it up as much as we could. So you can see that they deleted if a conflict occurs between the English and translated versions of this document, the English version will take precedence. So with the old ones, it was different. So there is a lot of languages out there now, and they've really worked with the industries throughout the different countries, and I think they've done a pretty good job on getting the translation. Okay, in the old Rev E, you can see here, this is new, into the Rev F, the personal proficiency, all instructors, operators, and inspection personnel shall be proficient in the task to be performed. Objective evidence of that proficiency shall be maintained and available for review. Objective evidence should include records of training to the applicable job functions being performed, work experience, testing to the requirements of this standard, and or results of periodic reviews of proficiency. Supervised on-the-job training is acceptable until proficiency is demonstrated. This is, if you were to do the J standard, you would actually see this in there. So they've just brought it over into the 610 itself. Here you can see Rev E where we deleted and changed it to the different paragraphs. Everybody can hear me, correct? I can hear somebody in the background. If you put your phone on mute, I'd appreciate it. Thank you. Okay, I'll see what I can do. I don't know why you can't hear.
He's probably doing a test to see what
I've got everything unmuted on my end. Can you mute yourself? Some of you, I'm getting your feedback, like Nancy, I can hear you. There's a lot of feedback going on here. Can you hear me now?
We can hear you, Nancy.
Okay. So here we're going to go on with it. Some of you need to mute your phone. Okay, thank you. So you can see here where the change, we removed level of acceptance and changed it to the word conditions for all three, or target, acceptable, defect, process indicator. Then we go into 1.5.6. Leaching has been removed, and you can see we've actually added in the word FOD, foreign object debris. Some of you still need to put your phones on mute, please. Please. Because I am getting a lot of feedback on this end. I can hear a few people still talking. Okay, there we go. So you got foreign Object debris, a generic term for substance, debris, particulate matter, or article alien to the assembly or system. In other words, it's not normal. You could have dirt, lint, dross, it doesn't matter. It's debris that's on the board that should not be there. Solder balls are spheres of solid that remain after the soldering process. It includes small molecular solder paste. They used to also call that, there would be like talking about solder fines, so they just put it as solder balls. Then we jump to paragraph 1.10. It used to say referee conditions are used to verify a product rejected at the inspection power. Now what it says, if the presence of a defect cannot be determined at the inspection power, the item is acceptable. The referee magnification power is intended for use only after a defect has been determined, but is not completely identifiable at the inspection power. So yes, you've noticed the defect. Now you're just verifying that defect of what it is. That's what you're doing with referee. Then you talking about chapter 3 or section 3 in the book. It's intended to be in general nature. This is, remember, this is a standard book, and section 3 does not have anything to deal with standards. If you want to know more, you go to ESD 2020. There was a lot of talk during the committee meetings of removing it. Then there was talk about making it an appendix only. So this is where they left it at. Left it in there for you all as good information, spec information or standard information. So remember that. Then we've got all these other changes throughout here, Revs E's and to Rev F. You can see the numbers have changed down through there. 4.1 component, heat sink for 4.14, used to be 4.13. So be careful down through there. Now, when this class is over, you will get a red line document. Now, there is some differences between the two, so go through it very slowly so you can see what the actual ones are. It took us a while to do this. Then now we added into paragraph 4151 under acceptability. It says no evidence of damage resulting from tightening of the threaded item. 4151 defects says threaded items are not tight and split ring lock washer, if used, is not compressed. See figure 421. Fastener torque value, if specified, is not within the limits. Hardware is loose. Evidence of damage resulting from over-tightening of a threaded item. Sometimes if you got like plastics, you can overdo that. Some of the smaller screws, you can overdo that too, especially if they're torqued. It goes on to tell you fasteners that other thread are. In addition to the threaded fasteners used for installation of an item onto an assembly, there are other types of threaded items that may be used in individual parts in the assembly. These may require tightening to a specific torque value or standard industry practice to include loosening or part damage. Such items include, but are not limited to, the connector, coupling nuts, connector strain relief, clamps, potting, molding boots, etc. Fuse, holder, mounting nuts, and any other similar threaded items. It also goes further on where torque requirements are not specified following standard industry practice. It says, however, some of these threaded items may be made of plastic or other materials that can be damaged. Again, like I said, if excessive torquing. It says accept Rev F, acceptable for all three. It says here, the thing we added is no evidence of damage resulting from over-tightening of the threaded item. Defect, threaded items are not tight, and split lock washers, if used, is not compressed. See figure 421. Hardware is loose, evidence of damage resulting from over-tightening of the threaded items. So you can see we added some words in there to make it flow a lot easier. Here on the left, we deleted wire wrapped around the screw body in the correct direction, but a few threads, strands have unraveled. This is like your, on your bus bars, around outlet stuff that you're going to wrap a screw or a wire around a screw head is what you're looking at. So here we got the defect. More than 1/3 of the wire diameter protrudes from under the screw head. Wrap more than 360. And a lot of others are just changing the figures up for you. Then restraining divided wire bundle securing. That's to keep them nice and tight. It used to just say, like it says up there, restraining devices are neat and tight and spaced to keep. It says now the restraining devices do not move. Restraining devices do not cause noticeable indentations or distortions of the wire or the assembly. Acceptable restraining devices does not have any longitudinal movement but may rotate. In other words, go around in a circle, but they won't move left or right. And this information here that we're seeing, if you ever went through the IPC WAMA Wire Harness Manufacturers Association 620, you would see this information right here, what we were just talking about. So now we're talking about some of the soldering anomalies, like 527 is entrapped, encapsulated, attached, fixed meets that normal service environment of the product will not cause particulate matter to become dislodged. The key word there is to make sure it doesn't come dislodged. So we're just talking about solder balls, anything that'll come loose. Next it's into 5212, and it says here, hot tears, shrinkage voids are generally found on the surface of solder joints. The connection with a hot tear shrinking void shall meet all other acceptance criteria. And it says acceptable hot tear shrinkage of voids. It says a crevice or a void in the solder joint due to solidification of the lead-free solder alloys during assembly process. Then we move on to 6112, talking instead of pad gap like it did in Rev F, we just said land separation. So it's acceptable for 1 and 2, we separate that out a little bit more. Terminal base circumference has more than 180 degrees contact with the land, with separations not exceeding 2 land thicknesses. Class 3, terminal base circumference has more than 270 degrees contact with the land, with separation not exceeding 1 land thickness. And if you notice, looking on the left-hand side, that used to be all together and to be acceptable for all 3 classes. Defect is less than 180 degrees contact. Terminal base has separations exceeding 2 land thicknesses. Defect for class 3, terminal base circumference has less than 270 degrees contact with the land. Terminal base has separations exceeding 1 land thickness. You can see where we deleted solder fillet at least 75% of the flange height. In class 3, no radial circumferential slits, 75% flange height. These have been deleted. If you look over here, minimum solder requirements for all 3 classes now is 75% or more of the land area is covered with wetted solder. Solder fill at least 75% of the flared flange height. Remember that's not to exceed 120 degrees of angle. Solder filler is 100% of the flat flange height. And that's when they're, like I said, that's like if you do an eyelet or something, you want it flat to the board. Then we jump to 6.2.1.1, talking about insulation damage or pre-solder. We've added to it the cut ends of some insulation materials, particularly those of fiberglass barrier, may show fraying. Acceptability of this fraying should be agreed upon between the manufacturer and the user. This criteria are also applicable to post-assembly acceptance. Additional criteria for damage is in 6212. So we deleted acceptable for class 1 for 622 is the clearance. Exposed bare wire provided there's no damage or violation of minimum electrical clearance. And then we jump down to 623, flexible sleeve. Remember, this is your heat shrinkable tubing that's going to be your new insulator after you've stripped the wires and or attach them to a terminal post or of some type. It says this criteria is intended for use for shrink sleeving. Criteria for the types of sleeving should be agreed upon between manufacturer and user. Cleaning, if required, shall be accomplished prior to shrinking of the sleeving. Heating processes used to shrink sleeving or insulation shall not damage the connector wire, sleeving, adjacent components, nor reflow the solder connection. There's some really good pictures in the 620 on where they've heated it up and the actual solder is wicked way up into the insulation area. So you got to be careful of how much heat you are using that you don't damage anything. We've added into table 6.2, we've deleted allowable and changed it to strand damage only. And it's for all three classes. You got the notes 1, 2, and 3. If you look down there, there's some changes to the notes. So it makes it a little easier. We've added for the number of strands 1 solid conductor. The old revision, it actually indicated and stated that you would refer to a solid conductor. So you do the 10%, just like it's showing there. So they actually brought it over and installed it. Then we go to 6322, and it breaks down that a little bit. From there, you go here and you go through all your little pictures. So what you're doing basically is taking table 6.2 and the 1 solid conductor across there, and you're making it 6322 also. It says no nicks or deformations exceeding 10% of the diameter, width, or thickness of the conductor. See paragraph 521 for exposed base metal criteria. Defect, it is more than 10% of the diameter, width, or thickness. Wire deformed from repeated bending. I always say that's like a hind crooked leg of a dog. It's deformed. People keep repeating bending and bending it over and over again. Should be a one-shot, one-kill deal. Then we're going into the table of what you're seeing is 30-gauge wire and smaller. Table 610 is applicable to 30 gauge. They actually added the table into here. So you can see when it's less than 9 degrees, it's a defect for all three. 90 to 180, acceptable. Defect for 2 and 3. 180 to 360, acceptable for 1. Process for 2. Defect for 3. Greater than or equal to 360 degrees, acceptable. In other words, we broke this, we put it into a table, and then you break it down. We, in 615, 616, we deleted the words terminals. We just said serious connect, because you know when you're in this section, you're dealing with wires and terminals. Then acceptable, we deleted a lot of information there you can see on the left-hand side. Unsleeved horizontally mounted components, unsleeved vertically mounted, sleeved axial glass-bodied adhesives. We're looking at the adhesive section. So this is going on with it now. They've relocated it. Continuous adhesive filler to the mounting surface and component body. Adhesive is cured. No gap, separation, cracks between the staking and attached surfaces. And horizontally mounted components of staking material adheres to the component for at least 50% of its length. The buildup of the staking material doesn't exceed 50% of the diameter. Minimum of 25% component diameter. D on one side. And this, if you want to know where I'm at, I'm on 7221. And then it just keeps on going. You got more information there on page 726. It says on vertically mounted components, the staking material bead as continuous for at least 25% of the component length with slight flow of the staking material under the component body. The staking material adheres to the component for at least 3 beads, spaced approximately evenly around the circumference, or for a minimum of at least 50% of the component circumference. Glass body components are sleeved when required prior to staking material attachments. Adhesive staking binding does not contact an unsleeved or glass body component. Sleeved glass body components has staking material applied to both sides of the component from 50 to 100% of its length and 25% of its height. Multiple vertically mounted components, staking material adheres to each component for at least 50% of its length, and adhesion is continuous between the two components. Remember, vertically mounted is standing straight up and down. Okay, so staking material adheres to each component, 50, and staking material adheres to each component for at least 25% of its circumference. In other words, going around it. Then on the next page, 727, you've got not established 1, process 2, defect for 3. The two items there originally have been deleted and what we've added to it or changed. It says here, for horizontally mounted components, stick material in excess of 50% of the diameter, provided the top of the component is visible. For sleeve glass body components, stake materials applied to both sides of the component, minimum 50% of the component's length. Then you've got not established for 1, but a defect for 2 and 3, which used to be a process indicator for class 1. So sleeved axial leaded components, except glass body components, does not have staking material in contact with both of the end faces of the component. Adhesive is less than 25% of the component diameter. Adhesive is greater than 50% of its diameter. Top of the component body is not visible. Sleeve component does not have staking material for minimum 25%. And then everything I just talked about, you look on the next page, 728, makes it a defect for all three classes. Then we jump to 733, found on page 735. And yeah, it looks a little blurry because we removed it from the red line document and just put it in here. So lead protrusion should not allow a possibility of violating minimal electrical spacing. We've deleted all that. It just says now lead protrusion shall be in accordance with table 7.3. And then you can look down here in note 1, remove manufacturer. Note 2, we removed the .050 and changed it to 0.05 inch so you can see it a lot easier because there was some confusion. And then added note number 3 as an exception to the discernible minimum lead length, see 7.3.5. And we're talking about the paragraph. Now we're moving on to table 7.4, which is several pages over. You're looking at page 740. And what they changed there was the vertical fill requirements. Used to state in the old one for class 2 that if you had a ground plane or a thermal mass, that the hole fill only had to be 50%. Now we've changed it for less than 14 leads. And then we've got with leads or 14 or more. So less than or greater than is what you're looking at. And this area right now, what we're talking about, they went into committee again to talk about it. So they're waiting for the beta courses to be completed. There might be an addendum to this section. They haven't officially said what they're going to do, so we're still in discussion about that. Sorry. Then you can see where we did in 7351, where we actually put what the table showed. We actually put it into writing. What is acceptable for class 1? What is a defect for class 2? What is a defect for class 3? Vertical fill is less than 75%. And then not acceptable for 1, approximate 2, defect for 3, that was actually removed completely. That used to be in the old revision. Now we're jumping to 753, just turn a few pages, well not a few, quite a few over. 753, where we're talking about jumper wires. It says acceptable for all 3. Is the second bullet, or the first bullet there, talking about the jumper, the wires not so loose they're going to extend above the height. Except 1, defect for 2, the wires loose and can extend above the top. So we deleted the 2 items there. Then you jump to 756, and you're going to be looking at the previous page, 755. We actually added a little statement in there at the bottom of that one bullet for jump wires 30 gauge and smaller do not comply with clause 614.1. And that's at the top of the page on 755, page 772. Then in 756, we deleted jump wires attached to components other than actually component leaded. Lap saw the wires of the component lead. And we've added the following criteria apply when soldering to a land or component lead and land. When soldering to a land, the available contact area is defined as the land diameter. and soldering to component lead and land. Available contact here is the distance from the edge of the component land to the knee. So acceptable solder connection extends a minimum of 3, and we're looking at that page right down there on 773, still in 756. We deleted the information from the Rev. We've added this. Solder connection extends a minimum of 3 wire diameters when the available contact area is at least 3 wire diameters. Acceptable for all 1 and 2, solder connection is 100% of the land or the land lead. The available contact area is less than 3 wire diameters. Acceptable for 3, solder connection is 100% of the land or the land. The available contact area is less than 3 wire diameters and staked or otherwise mechanically secured. And see what we've done here was added the staked or otherwise mechanically secured to class 3. Defect doesn't meet the requirements we just stated. Defect for all 3, wires that is lap soldered is less than 75% from the edge of the land to the knee. Wire extends beyond the knee of the component lead. Remember, if it's an RF circuit that and somebody's doing stuff, you can actually pull that back off of there or cause an RF issue. Lead violates minimum electrical clearance. Now we get into section 8. That was a lot of different arrangements, moving words, so hopefully it'll work better. So this section covers acceptability requirements. We removed all of that, dimension G, and what I put in there is in 912, or 812, I'm sorry, was the targeted was removed. It says this criteria is for adhesive added after component attachment. The circumference of bonding may have 1 or more adhesive points. Then acceptable, we add on round component adhesive adhere to a minimum of 25% of the component height. On round components, a minimum of 3 beads of staking material placed approximately evenly around the periphery of the component. Rectangular components are staked at each corner, a minimum of 25% of the height. Then down to staking does not interfere with stress relief. Slight flow under the component body does not damage the component or affects form, fit, or function. Now what sometimes happens when this adhesive cures, it can expand and actually crack your solder joints. So be careful with that. 812 not established for class 1. We're looking on page 85. Says round components where adhesive adheres to less than 25% of the component height. On round components, there are less than 3 beads of staked material. Rectangular components are not staked at each corner. Defect, no evidence of adhesion. The adhesive interferes with the formation of required solder connection. Adhesive is not completely cured and homogeneous. Adhesive interferes with stress relief. Then 921, you saw a lot of this stuff where it says plastic components. It used to be throughout areas, so now they've actually put it right here in the front. Unless otherwise specified, solder shall not touch a package body or end seal. Exceptions are when a copper leader termination configuration causes solder filter to contact the plastic body. Plastic SOIC family, spacing from the top of the lead of the plastic is 0.15. Connectors provide solder does not go into the cavity. Leadless components where the design land extends past the component termination area. When agreed between manufacturer and user. And again, these used to be throughout, especially like when we were with the gull-wing leads. It used to be the exception. Or years ago, Rev C and D used to be high profile, low profile. Then they went into with the Rev E, and they kept it with, and they moved it into Rev F. Is the SOIC and SOTs, as long as it's plastic body, solder can touch the package body. It is acceptable. Then the SMT connections are providing 831 through 8315. Talks about dimension G in here now. So they moved it from the very beginning of this, where it used to be right on the beginning of 8-1, they actually give it its own little location. So SMT connections target no evidence of tilted or raised component. acceptable component tilted, raised, does not violate minimum electrical clearance or exceeds maximum component height requirements or affect form, fit, or function. If it doesn't meet these requirements, it is a defect, and you can see that down below. And that is all found on page 8.8. Then we get into the tables. This is table 8.2, so you got to go several pages over. We're talking about 1, 3, and 5-sided components on page 8-15. You can see they removed the note in minimum fillet height. Remember that used to be the via holes? And then we, if you look, go down to minimum end overlap. All it said used to say it was required for all 3 classes. Now we've actually said that, you know, is for class 3R, which is, if you look down termination length, they've added that too. Tells you that is on your component body. That is its length. Okay, and they can vary in size. So it's 25% of R has to overlap the pad. They removed notes 7 and 8. Now it's 6 and 7. So if you read note number 8 on the down there, it says component size may be larger than a 1206 if the component is less than a 1.25 to 1 width to height ratio and has 5 terminations. So now what we did from the table, you go to 8.328, which is several pages over, but the already shows it, so it meets acceptability or it doesn't. It's a defect for class 3. Then 8.3.291, talking about the component sizes now, which was in that note, note number 8. Okay, still talking about billboarding, acceptable for class 3. Then you get your defects were deleted. It's just defect for class 1 and 2 now instead of all 3, because class 3 has a lot more. With the height ratio does not exceed 2 to 1, incomplete wetting of at least 3 terminations, less than 100% overlap, component overhangs the land, component has less 3 than termination sides. Again, it goes on incomplete wetting of at least 3 component terminations. This is your billboarding. Then it jumps into flat gull wing leads. So flip over there, the flat gull wing leads. We're going to look at the table right there, a little bit of it. We're talking about maximum toe overhang. There was a lot of questions, and if you look down at the minimum side joint length, when that was, and that was in the last revisions, it says when L is less than 3W, it has to be 100% of L. Now, if the toe overhangs the edge of the pad, you cannot get a full wetting, the full length of L. So they actually added that, not permitted when L is less than 3W. So then it cannot hang over the edge of the pad. Note number 4 change, solder does not touch the package body or end seal, but refer back to 8.21. If it's of the SOIC family or SOT, then it is acceptable as long as it's a plastic body. Now we're looking at 8.3.8.2, talking about the butt or eye connections. They've added some information to that. And this is what they, solder charge terminations. These are like on some of your Simtech connectors that they have. If you look at the picture on 878, figure 8139, you'll actually get a good view of that. And then some of the next few pages, like 8141, 8142, and that's filled with solder there, and then it goes into reflow. Okay, so maximum side overhang not permitted, toe overhang not permitted, minimum end joint width across there, it has to be 100%. Minimum fillet height completely fills bottom hole on the termination. Some of these have 2 holes in them, so you don't have to worry about the top one. And lead width is note 1. Land width, note 1, unspecified. So there's a good picture of what they look like. I said, Figure 139, 141, and 142 are some really good pictures of it. They're showed as side view on figure 44, I'm sorry. So this is a new style of connector that they've been using. Then 8391, flat lug leads, flat uniform leads, flat uniform flexible circuit terminations. They put that in there. You see it down at the very bottom on page 885, not at the very bottom, but at the end of the table. Maximum side overhang 50%, note 1, 25% for 2, and just 25% for class 3. Then your maximum gap, it's talking about M sometimes. Remember that there is no gap M. And then jump to table 813. Ball grid arrays. If you notice that they deleted the word spacing and said clearance. They deleted the word offset. Solder ball does not violate minimum electrical clearance. Offset is something that's intentionally done. This is something that just happens. It could be you offset it, and when it reflowed, or when it reflowed, it overhangs the edge of the pads too. So that's why they had to remove the word offset. And then they changed the voids from 25% to 30% voiding. And see notes 1, 2, and 3 on that. And then look down at the bottom. It talks about ball grid array components with non-collapsible balls. It says voids are not acceptable, period. And looking on column grid arrays, solder connection, it used to say external columns show complete wetting or filleting. Now it says all that has to go around is 270 degrees to be acceptable for all 3 classes. And when required, underfill is presently completely and cured. Now we go to table 817. This is your bottom thermal plane termination. This was your DPAC. So they give you change some things out. There used to be only a couple things for the thermal plane area. Now they've added a lot more. Thermal plane side joint link D, note 1. Then you got thermal plane termination width, note 2. Thermal plane land width, note number 3, which is unspecified. But note 2 says solder wetting is not required on trimmed edges of the thermal plane that expose non-wettable vertical surfaces. And criteria for the type of lead. So we've changed that up again. So you can see this is something new, and I have never seen one before, never used one before, but this is a P-style connection. It's like an edge connection. So you got your board, and this fits on the outside on both sides, and then it is surface mount soldered. So it goes through your ovens. So it clips in. So it's like an edge clip connection. Says here, this is all new, the criteria is applicable to both the toe and heel requirements of the connection. So if you look at 8120, you can see the toe and the heel on the sides there of that letter P that comes down. That's what we're looking at. So target fillet height is 100% of the termination height. Acceptable wetting is evident. Acceptable for 2 and 3 is 25%. Except for 1, defect for 2 and 3, it is less than 25%. And then we jump to 10.2.1. So there wasn't a lot of change in section 9. So we go to 10.2.1, found on page 10.5. It talks about crazing. It says see 10.2.5 for edge crazing criteria. Acceptable for 2 and 3. And we're looking at 10-6 page. Crazing at the edge of the board does not reduce minimum defined distance between board edge and the conductive patterns. Minimum distance is not specified, not more than 50% or 2.5 millimeters, whichever is less. What they did, again, is that when you're looking at some of these, you're not just looking at the 610, you've got to look at the 600 and the 6012 and see what their criteria is also. and bring it over into this and make sure it all flows, that there's no conflict between different standards. And then you got your defect. Crazing areas in line of substrate exceeds 50% of the space between non-common conductors. Unless otherwise defined, crazing at the edge of the board reduces the distance between the board edge, conductive patterns, more than 50% or 2.5, whichever is less. Defect spacing is reduced below minimum electrical clearance. So for the top part, Class 1 says still ship it. 10.22, blister, Class 1. Used to be all there, now it's defined out. The blister delamination spans more than 25%. But if you look at 2 and 3, the blistering delamination does not span more than 25%. So they separated that out a little bit more. Acceptable for all 3 is the distance between the haloing and penetration nearest conductive pattern. So you're looking at haloing. And that's found on 1010. Is not less than the minimum lateral conductor spacing or 0.1 millimeters, whichever is less. Defect, 1011. The distance between haloing and penetration is conductive is less than minimum. Then we go on to your conductor land widths, Nixon edge delamination. And this is all found on page 1018. If we were to flip over there, conductor and land reduction. They've deleted some of the minimums. It says reduction in the width of the printed board by more than 30%. Reduction in width or length, so on and so forth. So they deleted some of the words out. And in 1032, we deleted, except as noted, this criteria is for lifted pads with or without a lead and a via hole. And then go to 1084, which is quite a few pages over. And it talks about electrical insulation coatings. So they added this material is used to provide insulation to exposed conductor when conformal coating is insufficient. To provide enough protection, encapsulation is too much. All of the considerations used for conformal coatings are applicable for insulating coating except surfaces coatings applied. This was all revamped, even in the J standard. Insulation coating thickness, complete coverage, no exposed metal. Defect, exposed metal. So this is some of the main changes. There wasn't hardly anything in section 11 either, any changes whatsoever. I hope you enjoyed this. Again, my name is Norman Mier. If you have any questions, you can email me at solder.net, nmier@solder.net. We are taking any questions at this time if you have any. If you will be receiving the copy of the red line document, also an unabridged version of this webinar. There's over 190 slides, and I reduced it down to approximately 70 to get this all in here within 45 minutes to an hour. If you have additional information, you can contact Katie Radcliffe. Her phone number is on the screen right now, along with her email address. So is there any questions at this time? Well, I hope you enjoyed it. Again, my name is Norman Mier, and I'm an IPC-A-610 MIT working for Best Incorporated. I've enjoyed this, and have a nice day. Thank you again. Bye.